right. So, hello everyone. This is actually sad to say, but it's our final technical walkthrough in the series of technical walkthrough calls for the Fuel Network Attackathon. Yep, it's the sixth one. It's quite fast. I mean, like I remember as if it was yesterday, the first one. But nevertheless, today we're discussing how to use Sway Analyzer as the main topic of this technical walkthrough call. And we are joined by Angelos from Ourovoros team. Amazing, even more exciting guests. Welcome, Angelos. Exciting to have you here.
Thanks for having me, guys.
Of course. Just to finish this off, guys, for those of you who don't know, and for those of you who are going to watch this in recording, we're all doing this as a part of the educational preparations for Fuel Network Attackathon, which is the biggest attackathon right now in the industry. And you have up to $1.3 million to grab in there. The attackathon is already live for 2 days, and we know that already some bugs in there. So those of you who are sitting and listening, well, I mean, it's good that you're listening, but like other guys are hunting out there. Joking. You still have time. You still have 30 days to go. But that being said, I'm going to pass this to our one and only Adrian, who is our head of triaging, and Angelos from Ourovoros team. Guys, take it away.
Okay, thank you, Tim. Thank you. So, as you know, Fuel Network consists of different things. And one of those new things that Fuel Network came up with is the Sway language, which is kind of similar to Solidity, very heavily inspired by Rust. But Sway is a language that is used to write smart contracts. And as Solidity has its own slither as a static analyzer, Ourovoros and Angelos here created a Sway analyzer in similar fashion on how slither works for Solidity. But I'm not expert in that. That's why we have Angelos here, who actually was very kind to agree to join and talk about the Sway analyzer. So I will give it to you, Angelos, and if you could also introduce yourself. By the way, this is my dog. That part is actually still white because, by the way, my daughter threw food at her and we were eating tomato pasta. So yeah, but I'm digressing. Angelos, please take it away.
Thank you for the introduction, Adrian. So I'm Angelos. I'm Greek, as you can already get from the name. So we at Ourovoros are a collective of Web3 security experts. We have a strong background in smart contract auditing, and lately we've been meddling around with Web3 development and, of course, blockchain tooling, as Adrian mentioned, the Sway analyzer. So after getting in touch with the Fuel guys and getting to know the ecosystem more, we decided that what was missing from the smart contract scene was a static analysis tool that would help smart contract developers basically deploy more secure code in the Fuel blockchain. Of course, having a background with Solidity smart contracts, Slither was the go-to option for everyone in the space, so it wasn't a new idea that we tried to meddle with here. But yeah, that's all from the background, from the history that you want to know. And yeah, Sway Analyzer is basically, like Adrian mentioned, is a code analyzer, static code analyzer. To be more specific, it's a security-focused static analyzer. It's written in Rust, but it's for the Sway language. As you know, those two languages are pretty similar. And what this tool basically does, it analyzes Sway source code. It generates its AST, which is a short version of abstract syntax tree. I'll be using this abbreviation from now on, so sorry about that. And using that AST, you can leverage that AST and algorithmically, let's say, analyze it and scan it and try to detect things in the AST. So to be more specific, when you write your smart contract in Sway, you have your main.sw file, which is the main smart contract that you're going to deploy. and it's basically a module. We call it module in Sway Analyzer, and you provide the path of the module or the whole directory if you have multiple SW files. And yeah, it basically generates the AST for you. And we have a list of detectors, which basically try to detect things in the analyzed code. I don't want to get too technical into how it does things, but I want to say that it basically goes top down in the AST structures in the code in a context sensitive manner, which is it gets the module path, which is the main SW, and then it goes through the code, it goes through the use statements, it goes the imports basically, it goes through the storage block, which is the state variables, if you're familiar with that term. And yeah, it goes in the ABA block and what have you, right? So there are ways to algorithmically iterate over the AST. And yeah, that's the background knowledge, which if you're not extending the tool, you shouldn't care too much about. What you should care about though are the detectors, which is a list of analyzers basically. So you can analyze the codes for specific things like outdated storage values, or like locked native assets or arbitrary asset transfers and stuff like that. So those things are part of the list, the detector list. And yeah, I think I can share my screen and oh no, so I cannot share my screen.
Uh-oh.
Oh,
Why?
it's not available for you?
Yeah. Adrian, can you go to the GitHub repo for Sway Analyzer and go through the README? It's gonna be like pretty plain.
Yeah, opening that right now.
Sorry, guys.
No, not insurance. GitHub Sway Analyzer.
So as Adrian is searching for it, we have like a short story to share. So basically, those detectors we have categorized into 3 severities, which are like red, yellow, and green, similar to the traffic lights. So like I told you, similar to traffic light, if the red light, if the light is green, you can pass the crossroads, and if it's yellow, you have to be strongly considerate. But if it's like absolutely necessary, you can pass, and if it's a red light, you have to immediately stop. So that's basically the categorization like for all the detectors that we're making. So you can have like stylistic detectors, like optimization ones, which we mark as green, and you have the red ones, which are like I told you before, ones involving locked assets or like outdated storage lookup and unmanaged external calls. So as you can see in Adrian's list, we have a whole, in this screen, we have a whole list of detectors, which are in the format of like severity and a small description afterwards of what it does. And yeah, so you have 2 ways to install the tool currently, and I don't think there is a plan for another one.
Yep.
You can either install it through Cargo, with just Cargo install Sway Analyzer, or you can clone the repo, get into the directory, and build the Cargo project and update your path variable and environment variable. And that's all you have to do basically. You just need to have Rust and Git installed, and you can use the tool immediately. You don't need the fork toolchain in order to use it. You just need, like I told you, Rust and Git.
Question: how often you notice those different issues being actually in different Sway contracts? For example, arbitrary asset transfer or locked native assets. How often, when you run this Sway Analyzer, such issues actually come up?
Yeah. So most of the detectors, like given our experience with Solidity language, we have tried to port over similar detectors or like similar vulnerabilities from EVM-based ecosystems. And we tried to make it custom to the Fuel VM. Of course, it's not just there to be like there are actual vulnerabilities. To be honest, I haven't had them come up too often. So the guys like that got into the Fuel ecosystem are pretty familiar with like how native assets work, how you mess with asset ID and stuff like that. So it wasn't that we've come across a lot, but we expect new users that especially come from the EVM based ecosystem to be more, let's say, to be not so familiar with the whole spectrum of Fuel features. And a good thing that you can do, if you go up in the test directory, up in the Adrian.
Yep.
So we have a test directory which is full of Sway code. It's one Sway smart contract per detector to be exact, and it basically gives you an example of what that scenario will detect. So if we go on that one that Adrian just entered, so you can see that there is a withdraw function, but the withdraw function doesn't actually do anything. So you can send assets to it. You can see that the deposit functions are payable, so you can send native assets to that smart contract, but the withdrawable functionality is empty and it doesn't affect the native assets at all. So you should expect. We have some comments up on top about the entries, as you can see in line 18 and line 26. That should be part of the CLI output. So in case you run the tool against that smart contract, you would have those two outputs. Another thing to note is that is like how you use a tool. You basically build the cargo project and then you have some options. You can use the dash help to see the whole spectrum, but as you can see over at what Adrian is sharing, you can specify. So if specific detectors, for example, if you want to search smart contracts for locked native assets, you can only use that detector. If you don't specify anything, which is the recommended option, it will use the whole list of detectors. You can specify the directory, or you can specify specific SW files, as you can see up on top. So with the dash directory, you just give the directory, the path to the directory, and it will analyze all the submodules in that directory. Or you can use the dash files to analyze a specific file. Personally, I like the dash directory just to like not give too many arguments in the tool. We have the ability to sort the output in the CLI, as you can see with dash sorting. And we have, which it's a new feature, which I don't see it being there right now. There are two more options. There's the dash include or dash exclude to include specific severity. So if you want to only search for like high severity findings from the Sway analyzer, you will use dash include high, and it will get only the red, basically, the red colored detectors. So basically, this is a CLI tool, but we have opted to have a JSON format that is not recommended to use right now, but in case you want to make it part of your CI, or you want to have like a tool that extends the current Sway analyzer, or you want to use it as part of your UI or what have you, there is a JSON format for the outputs and everything you would need. But the recommended use is like a CLI tool, basically.
Okay, I will just, as I don't have the tool installed and I don't even have Rust installed on my laptop, let me just quickly find the article that you wrote.
Yeah.
So I can actually see the...
So
okay.
I have written an article like the past couple of days. It was released like a couple of days ago, and you can refer to that. It has like a whole walkthrough of how to install the tool, like what the output should look like, how it works. There are some examples. There are like some explanations for the flags.
Yeah, the exclude include, something that you mentioned is in the.
Yeah.
Yeah.
It is. And we'll have some examples over here. As you can see, I have opted to run the tool against the Sway applications, which basically some boilerplate code that the Fuel guys have released to help us know more. As you can see, for the first example, you're using it in the NFT directory, and we're using the detector. Basically, whenever you use it, you have an identity, or you can call it an address in the EVM terms as an input parameter, and you don't check if it's against the 0 value. This detector will give you an output, as you can see over here. Like the function mint in the contract does not check the recipient parameter for the 0 value. So I'm guessing that it's a normal minting functionality, and the to address where the asset should be minted is not like checked against, right? So you can basically mint to the 0 address, which is against, let's say, the minting standard.
Okay. We have a question from Building EVM. Not sure if you can actually speak. If not, then please just type your question in the chat.
Yeah, Building EVM. I propose you to type your question in the chat. It would be more easy for us to read it. Angelos, I think you can continue in the meantime.
So yeah, how you wanna use that tool, right? And why?
Yeah.
So basically, static code analysis is very important to have through the whole development process, and because it's something cheap and something quick that you can just check your code against. It should be done from the very first iteration of the development phase. So it's important to use static analysis in general in order to have like better code quality, improved code quality. You can have like we have some optimization proposals over there. So you will deploy less bytecode in the ecosystem in the network, so you will pay less money. Of course, Fuel is supposed to be super cheap, but the less you pay, the better for you. Basically, you should have like static code analysis as part of your security assurance, let's say, scheme, whatever you have in place. And like static code analysis, because we're only humans and we can only be focused for like only so much. Like it's supposed to help the development process to like detect vulnerabilities as early as possible, and it's supposed to like be like a stressless tool that will help you detect some boilerplate findings that you have to run through the whole code and try to go function by function and variable by variable and see that's and do some like get your hands off some tedious work basically.
Okay, makes sense. And what are the most common Sway issues that you have noticed? Of course, you have some most common Sway issues already as detectors in the Sway analyzer, but from your own experience when you were looking at the Sway code and deciding on the detectors, what struck you as the most common mistakes?
So the first thing that I've personally have identified is the way that storage works for Fuel. You can read from the storage. Oh, yeah, thank you for sending the link. You can read from the storage. You can write to the storage, but you have to read to the storage after the write. So there can be inconsistencies between storage throughout the function. So if you read the storage, like specific storage variable, and then you update it later on and use the local instance that you first read, then you have an incompatibility between values for a specific state variable. So because it's a little bit different for EVM and Fuel VM, like anyone that comes over from the EVM expect this to be not an issue, basically. But this is something that we have like first come across. Another thing that we have come across is the inability to like handle the native assets as a whole. As you know, Fuel VM, like one of the features of Fuel VM is the ability to have multiple native assets. And basically, if you follow the standard, whatever asset you're supposed to bridge to Fuel VM, you can use it as a native asset. So, for example, for the Ethereum, you don't have to spend Ethereum for the transaction. You can use your USDC. That's the whole concept of the multiple native assets. So how you handle the native asset is something that we've come across either on vaults, the deposit withdraw function that I mentioned, or like when you transfer the native asset. For example, we could only transfer one specific asset, and like all the other ones will be locked in the contract. So yeah, this is the second one, and I think the third and one of the most important ones is the one related to one of the new features that Fuel VM introduced. It's called the LDC opcode. It's basically an instruction that allows you to load code from another address and use that logic into your smart contract. It's not like 100% a delicate call, but you can think of it as a delicate call, like if you want to have like a small like mental picture. So you load code from an external address and you use that logic in your code. So because you load code that you have not whitelisted, you're not 100% sure if that address is part of the input of a function, part of the arguments of a function that you provide, then it can get messy very quickly. Either when it comes to like the storage like versions and the logic itself, of course, right?
Okay, awesome. Thank you. And are there any questions to Angelos here from the audience? Okay, we have a question. I have a question related to one of the topics Angelos covered regarding common issues. So there is no equivalent of item storage in Fuel VM Sway. Sway only acts like item memory. Is that right?
I'm not 100% sure about the new implementation of the storage vectors. They're part of the testnet, but I can say for sure that I cannot answer that right now. Like that thing that you mentioned is basically our thought process when it comes to the detector I mentioned before, like the outdated storage, how you read and write. I think it's fixed in the latest version. I'm pretty sure it's fixed in the latest versions. I'm not 100% sure, but yeah, that's basically the thing that we had in mind when we first made the detector, the aforementioned one.
Okay, awesome. Are there any other questions? Let's give it some time for people to type everything into the chat. Okay, team, do you see maybe any questions from the Discord?
Let me check. Nope. Very quiet there.
Okay. Can I add something, guys?
Yes, please. Please do.
So basically what we've done is we have created the backend of the Sway analyzer, and what the report, basically the output of when you run the tool, what you get as an output is part of the detectors that you use. We have created a set of like detectors that we think should be in place, and we heavily encourage the whole ecosystem to either extend the current detectors with more like examples that they have in mind that this detector is valid for, or like try to propose new detectors. Of course, if they're not too familiar, because we have created a framework to be able to create your own detector. If they're not too interested in doing that, or if they're not too familiar with the language and our framework, please make use GitHub as as a medium, and try to open PRs, like open cases that, for example, you have run the tool and the detector didn't show anything, but the vulnerability that you have mentioned is still valid. So we want to have the community engage, use the tool, get us more feedback as we can, like make the tool better. Right now, Sway Analyzer is in a beta version. So yeah, more detectors should come your way, like more robust detectors from the existing list should also come your way, like basically eliminate the false positives as much as possible. But yeah, the static analysis is a tool that you use it and then you discard some false positive and you only keep what you think it's important. But yeah, we will try to make the existing detector list more robust.
Okay, amazing. Again, thank you, Angelos, for the presentation. Okay, we have another question. Wow, awesome. Is there a guide on how to build custom detectors?
No, but similar to how I've created an article about how to use Sway Analyzer, I'm planning in the next couple of days. Of course, we have another article that's coming your way about potential Sway and Fuel vulnerabilities. But after that one, we are expected to make how to make your own detector.
Awesome, amazing.
It's going to be part of Medium and Substack.
Okay. Thank you for this. Are there any other questions? Okay, I don't think so. So again, Angelos, thank you very much for joining and giving such a nice and concise presentation regarding the Sway Analyzer. Looking at the comments, people enjoy that. I also enjoy that. And yeah. Guys, if you have any questions, please reach out on Discord, on the Immunefi Discord regarding Fuel Network Attackathon. Team is there monitoring everything, keeping a pulse check on everything. So whenever there will be some questions regarding Sway Analyzer or something else, we'll make sure to get you answered. So again, thank you very much, Angelos, for joining. It was a pleasure hosting you, and thank you all that joined, that you actually joined and asked all those lovely live questions. And yeah. Happy hunting. Remember, $1.3 million is to be won over. So you don't want to miss that. People are already submitting bug reports. So yes, I'm building a FOMO for you guys, because if other people are
yeah,
if other people are submitting bug reports, why can't you submit a bug report? Please do that.
All right, guys. All right. I think I should end this. Yeah, Adrian is just Okay. I'll save you all. Thank you, everyone. This was a wonderful journey together. Check out all the technical walkthroughs on our YouTube. And yeah, thank you, everyone. Now, just good luck with the Fuel Attackathon. Thank you.
Thank you. Take care. Bye-bye.